Well, it is Tuesday, March 4th, and it's Happy Mardi Gras. Yay! Happy Mardi Gras! So today we're going to talk about dividing exponents. So of course we want to put our date here. Where are we at? So we got 3, 4, 14. And we've talked about exponents to the zero. We've talked about negative exponents, multiplying exponents, and now we're going to talk about dividing exponents. So a dividing exponent problem looks something like this. We might have, we'll just start with something simple, like x to the fifth over x to the second. So the first rule is you can only divide exponents of like bases. Okay, so that means an x with an x or a y with a y. So if you think about this, x to the fifth means x times x times x times x times x. And then x squared means x times x, okay? Now, side note, we know anything over itself is 1. So 4 over 4 is 1, 10 over 10, because that's 10 divided by 10, one group of 10. Or if we had x over x, that equals 1. Or if I had smiley face over smiley face equals 1. So anything over itself is 1. So if I go over here and look, I have an x divided by an x. So this equals 1, right? And here I have an x divided by an x, which is 1. And that's all multiplying. Okay, so here we can cross these out and make them 1s, okay? And so you should know that 1 times 1 is 1. And then we have these x's left. So there's 3 of them. So x times x times x is x to the third. Now we can put times 1, but anything times 1 is itself. So we know our answer here is x to the third. Okay, so basically we drew out what we had, we crossed off our top and bottoms, and then what we had left was our answer. Okay, so let's look at another type of problem. Let's say I had y to the second over x y to the fourth. Okay, so we're going to write that out. That's y times y, which is y to the second or squared. And then we have x, and then we have y times y times y times y. Okay? So I just wrote these out in expanded form, right? So again, I want to look at where my like terms are because the same number over the same number is equivalent to 1. So if I go over here, I have a y over a y, so I can cross those out and it just becomes 1. And I have another y over a y, so I can cross that out, and that's just 1. And that's it. So I'm left with 1 times 1 on the top, which is 1. And then I have this x here, nothing kind of paired up with that, so I leave it. And then I have y times y left, so that's y squared. So my answer is 1 over xy squared. Does that make sense? Okay, so let's look at another example here. So scroll this down a little bit, maybe not. Let's try that. Okay. So how about if we have, let's see, x second y to the third over xy squared. Okay. So I'm going to write this out in expanded form. I've got x times x times y times y times y all over x times y times y, right? Okay, so now we're going to look for our pairs. So remember, you can only divide of like bases. So I can only do an x with an x and a y with a y. So here I've got an x with an x on top and bottom. So remember, x over x is 1. So I can cross that out, make that a 1. And then here I've got a y and a y, so that makes that a 1. And I've got a y with a y, so that makes that 1. And I don't have anything else. So now we're going to look at what we have. We have, remember this is all multiplying, so 1 times x times 1 times 1 times y, right? So essentially I've got all these ones, so I'll have a 1, and then I have an x times a y, right? 1 times x times 1 times 1 times y over nothing. Those all crossed off, right? So then I can just write this 1 times anything is x is itself. So I can just write this as my answer is xy. Okay? So let's try one with a coefficient now. So let's say I have 4 x to the third y squared over 2 x to the fourth y to the third will go. Okay, so the first thing I want to do is write this out in expanded form. I have 4, then I have x times x times x times y all over 2 x, 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 and y, and y, and y. Okay, so now we're going to simplify. So these are like terms, 4 over 2. So hopefully you know 4 over 2 is the same thing as 4 divided by 2. So it's just going to give me 2. Then we've got these x's, and these x's. I'm getting a little squirrely here. And then I have a y here and a y here. So those all become 1. So then I want to look at what I have left. All the ones on the top got paired. And then if you look at the bottom, I have an x and a y left. So that becomes 2 over xy. And that's my answer. Now, if you look at the power rule, the power rule says that when you divide, you subtract. Okay? So let's look at how that rule applies here. So if I go back up to here, the rule, and sometimes this rule I find confusing. I kind of like the crossing out better, but I'm going to show you the rule anyway. The rule says that when you have like x to the a over x to the b, you can do x a minus b. Now I probably just confused everyone there, but let's look at how this rule applies here. So if we were going to use this rule in this situation, I would put my x down, which happens to be x in this case. And then my a is the top exponent, which is 5, minus b, which is my bottom exponent, which is 2. And so then that would become x to the third, which is what we had here. Okay? So let's see how this rule applies down here now. Okay? So remember, you can only do it with those of like terms. So my y is going to stay here. But when I look at this rule here, let's do it down here. I have y, and then my a is 2 minus my b, which is 4. So that's going to give me y to negative 2, which means I need to have 1 over y squared, and then I have that x in there, which I get the same thing here too. Okay? And then if we look at this problem down here, for my x, my a is 2 and my b is going to be 1. So that's the a, that's the b. So I'll have 2 minus 1. And then for my y, my a is 3 and my b is 2. So it's 3 minus 2. So that gives me x, 2 minus 1 is 1. And y, 3 minus 2 is 1. So if you look, we have x times y, which is the same thing we got here. To me, this process, even though it's a little more work, makes more sense. But if you're fine with the subtraction of exponents, you can use that shortcut. And it works here. Here we have 3 minus 4, which is x to the negative 1. So I put it on the bottom for x to the positive 1. And then for the y, we'd have 2 minus 3, which is x to the negative 1, which we put on the bottom for y to the positive 1. Okay? So you guys try this one real quick, and then we're finished. Okay, I know it's a little bit longer, and I apologize. All right, so here's your practice problem. 5, a to the third, b to the fifth, over, actually let's make that 15, 5a squared b to the 7th. See if you can come up with the answer to that one. And we'll talk about it tomorrow. Happy Mardi Gras, Fat Tuesday. Eat some punchkis. You probably don't know what that is if you're from the South, but that's what we do up north. We eat punchkis on Fat Tuesday. Good night.